All right, so this is the little sizzle reel. This is going to be a little sales pitch, but I want to go over what I came up with to get all these standoffs done. You know, leaving the meeting like we're talking about with the potential of 350 of these to knock out, to tack them first, get him ready to weld and stuff like that. So I spent last night, the evening, basically, I worked to get the discovery frames out. So I got it done. And after I was done last night, but I was spending all day trying to figure out how to do this. And it kind of came to me, in my mind. I'm thinking of all the things that I know of, like I've seen before on how it's made, all my documentaries. And so what a lot of factories use is pneumatics, pistons, air pistons, things like that. I've always thought about getting into pneumatics, but never really had an occasion to. But anytime we do a high production run, my mind starts to envision how it's made, knocking stuff out in the factory and little robots and pistons going. Pss, pss. So last night around 10 o'clock, I went down a rabbit hole and started to go into what does it take to do fixturing, air-powered fixturing. And so Rockler popped up. I didn't even know they had this system, but Rockler is mostly for woodworking. Think like Casey and stuff. So it's not really on our par, but inadvertently, this guy essentially gave me a crash course. Once I saw him explaining the kit, unfortunately for him, his explanation gave me everything I needed to just go crazy. Once I saw what they're selling, I realized that all of this stuff, raw material, is in McMaster-Carr. And then what he did is, unfortunately, instead of selling me his product, he showed me a crash course on how to do pneumatics and to do all this fixturing. So once he showed how it works, I'm like, thanks, guy. So I started to then do a deep dive. And by 1 o'clock this morning, I was an expert at all things fixturing and jigging and how to do all this stuff for us. So you can see here he's using these little fixtures. He flipped a switch, it holds this in place, and he's doing that. But what's really cool is the almost unlimited possibilities that pneumatics give you as far as, at the drill press. Yeah, this would be great. But all this stuff doesn't need to come through this kit. We would just use it through McMaster-Carr. So then McMaster-Carr, I started looking, and they have these pneumatic hold downs. This is what we would be using to hold down the plate. They sell these things here. And then I even stumbled across this guy who is using this system. Again, you recognize you got a switch up here. You run your air power to it like he does there. And then he's created his own fixture system here, and they sell these as well. So these are linear, and then they smash down. And so you flip the switch and you see what it does. It just pushes down and it's going to cement those together. So I think he uses it right about here. There you go. So it goes up there, gets those good, boom. So you can see where it holds, and it keeps constant pressure. But you can see all this air line and all these fittings are all just basically Lego. So once you kind of invest a little bit, so that's what I'm kind of trying to pitch, is that we do the upfront investment. If I could get a little budget from you, we get some money, and then we can go ahead and get McMaster-Carr, and we can get like a starter kit. Everything we need for this. And then this is kind of what I was thinking. See, this guy has it all figured out. He's explaining how all this works. But all this stuff is off the shelf and it's modular. So you buy these different things to do different things. And then you buy the switches, right? And then you can, the tubing is $20. You get 100 feet. So you can mix and match and make your own tubes and make things. So you can see this is what I was thinking exactly when I saw what this guy's got. Just little bins. You have your different nozzles and different elbows and things like that allow you to custom make whatever configuration you want, and then you just snap in all your lines. And so and then he's showing you this is exactly how it works. So all of this stuff's off the shelf, different pistons at different sizes with different strengths to do different things, but essentially it starts with this switch, and then you can do whatever you want, run all that. So I then went to McMaster-Carr, which is an amazing resource. And I went to town, and by 1 o'clock, I was an expert. And so this is what I cooked up. So I woke up Fusion last night about midnight. And this is Allah. So with a little bit of upfront, like I said, if we can use this to amateurize to get us into pneumatics, I see this as getting our tacking station for our vertical and our little plate here, getting it down to about a minute per. So this right here would be constructed out of 09, real simple. I'd bend it, fold it, and all this would just be riveted together. I didn't have time to put rivets. This right here gives us adjustability. These are 5/16 riv nut, so I can slide these plates a little bit to get it dialed in properly. This right here is a little air piston, McMaster car. I didn't bother to put the fittings and everything, but I did put the fittings in here, downloaded the fittings and everything, and I learned how to do a curve like that and made a little tube. So I taught myself that. But here's your switch, as you see in the videos. And then this one here would be a single type switch that would run that piston. Theoretically, we could run everything off of one switch where it all activates at once. But these pistons like to run at full pressure. Our pressure on our shop is about 100 PSI. These guys here only want to run about 30. So much like in that Rockler video, you got to kind of step down. So we would run a regulator on these guys to bring our 100 pounds down to about 30. So this would run all these guys in one run. You just flip a switch, all these guys would open, and then this switch would push this back and forth. So the idea is you flip the switch, this will push this up against there. You hit this switch that clamps down all four sides, 200 pounds, keeps this flat. So I see it as flip a switch, open, drop in a plate, flip a switch, locked. You take a pipe, you put it in, you bonk it up against there. After the first time, you get it all dialed in so where these guys are going to be nice and square. And then you flip a switch, and where does it? Oh, I'm still learning 3D. You flip a switch, this guy, that piston locks it in, and then we're going to go ahead and tack it probably on three sides, 1, 2, 3. That way it keeps, because if you only tack it on one side, then the heat from the tack right there will bend this towards that, and we're out of square. So you want to do at least 3 tacks, if not 4. So, and this thing here, these things look huge, but this thing's only about 5 inches long, and it's only about 2 inches tall, because that's a 4-inch plate. So this right here, like this assembly is only as wide as that. So this looks huge, but, and then the idea is that you see all these fittings, like that guy in his like modular system. We would keep this jig for future use, but we would undo these guys, and these guys can go on the shelf, and then anything going forward, we could use it again and again. So theoretically, we've got ROI for every job we do that'll have a lot of things. And then we can accumulate these little pistons. These pistons are only about $40. I say only, but you could have several of these, and all you do is just put a hole right there, and you bolt it in, and we're good to go. So, and then this little bumper is like $3. You thread it on there, you get a bumper. So, you know, again, it's the modularity, it's the Legos. What I really see this is like these things would be cool, I think, if you're doing a high production run in the laser department or something. So you could do like, you could take a, oh, hold on. There you go. I don't want to do a sketch. So you could take 2 of these. You could put one like on over here on this end of the board, and you can take one of these and put it over here on this end. And then you could flip the switch and hold it down, and then you could do grav apply or something, and then flip a switch and undo it. And you can, you could route like a panel or a board that'll have like a reference jiggy things and stuff. And then you can just click, 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 make it happen. So anyway, so that's my sizzle reel. This is what I see. I can get all this bent up. If we're down, I can get all this stuff ordered, and it'll all be here by Tuesday. And then the other part that I want to show you for the automation is I already ordered this guy because it's only $200. So this is something Ernie wanted when Ernie worked here, but we never bothered to get one. But this is what they call a welding turntable or a fixture table. What this does is it allows the part to spin. It has speed control, so you can make it go faster, you can make it go slower. And you can actually adjust this and make it custom. So you could actually take this plate off, like you can see there, and we could actually make our own jig for whatever we want to do. So the idea is this guy here has the ticket. So this is what we would do is you can see here that this is actually sped up. It wouldn't go this fast, but they made themselves a little custom table there. You can see, And then you just kind of get yourself a little rest, just something that works, that you can put your hand in the same place every time, down and dirty. And then you can see where they have them in the center there. So I can see where we'll take our, little standoff once it's tacked, and we just stick it on there, leave it spinning. This guy here actually uses it, and he kind of uses it in a weird position though. All these guys like to think they're professional welders, but you can see where it's spinning, and you just keep the gun in the same place, and ours will go actually a little faster than that. He's welding steel. He's going a little slow, but ours will have a little bit higher RPM, but you just keep it in one spot. It keeps going around and you weld it up, and our welds will look a lot prettier. So anyway, so that's the idea. Clamp this up, bam, bam, bam. I can see this being done, if we get these down to a minute each, which actually would be quicker, 360 round numbers divided by 1 per minute, 60 an hour. You're looking at about 6 hours to knock these out. Add in some coffee breaks, let's say 8 hours to do all these tacked. And then if we're doing this spinny thing like this guy's doing, I could see doing these 1 a minute, maybe 1 every minute. So again, you could be 8 hours getting these welded using this spinny guy and getting, once you get it dialed in. But I could see maybe 2 days getting all these welded, 16 hours, and I could see 16 hours getting this with a little bit of investment up front and getting us into pneumatics. So anyway, I'll conference with you, see what's up. But if you like it, I'd like to get all this in play and get all this stuff going. So anyway, that's it.